Hi, this is Omar from Droop Consultancies, and I'm going to present here the Astronomy calculator, which is an application that we have created in Access VBA, and you can download it free from our website. There are two types of this application, 32-bit and 64-bit, and we are going to use here the 64-bit application. Double click. I created this program first time in Excel VBA in 2017. I've just recently transferred it to Access VBA. At that time, 2017, I had an idea about how to determine the first appearance of the crescent on Earth in order to identify the first day of the lunar month. And I wanted a program that can generate a large set of data in order to do the compare and contrast analysis to see if my idea can work. And I couldn't find a suitable program to my requirements, so I decided to build my own program. I found a book for Peter Duffett-Smith with the title Practical Astronomy with Your Calculator, and most of the equations I needed were inside this book, so I just transferred it to Excel VBA. And I did use some equations and VB codes available in the internet as well, and I put all the references related to this program in the notes. So if you click at Options, Notes, this is the introduction and references. Click. This is the introduction, and these are the references, and this is the reference for Peter Duffett-Smith, Practical Astronomy with Your Calculator. And there are many references here. For example, in this program we have 4 pages of graphics, and we used the tools in image class, which was provided by Stephen Liebens, and this is the reference for him. And I need also to give credit to John White, as he managed to modify the image class so that can work with the 64-bit MS Access applications. I need to say here that my original idea that I started this project with in 2017 turned out to be inaccurate, and I realized that very quickly after starting this project at that time. But it was a useful one because it guided me to a very good and very important ideas, and actually I wrote 3 Arabic books and 2 English articles about my findings using the Excel VBA program. These books and articles, you can download them free from my library website, and I put the reference for them. This is the reference, and this is my library site. This application follows a color standard. So if you click at Options, Color Code, and this is the color code for this application. A button is an action box. If you click at a button, there will be action. The red box is also an action box. If you click at one of these boxes, there will be actions. The orange box is a zoom box. If you click at it, it will give you a note. The flat white box is a read only. So these 2 boxes are read only. You cannot change the data directly at these 2 boxes. You need to click at the attached action box. The depth in box, the sunken box, is read and write. So all of these boxes here are read and write, and you can enter data directly here. This is the data entry area. This here is the data table. The object at the moment pointing to the sun, so this is the data for the sun related to this specific location, latitude and longitude, and this specific date and this specific time. This is the control panel, and this is the attached image. As we said before, there is 4 pages of graphics in this application, and this is the first one. This image plot the location of the sun in terms of the azimuth and altitude for this specific location at this specific date at this specific time. Returning back to the data entry area, the most important data that we need to enter to the system is your local data, your location in terms of latitude, longitude, and most importantly, your time zone, because the system will recognize the current GMT time, the Greenwich Mean Date and the Greenwich Mean Time, which is the universal date and time, by taking the time from your computer clock and deducting from it your time zone, your local time zone. You can enter your local data by clicking at latitude, add edit local data here, or longitude, add edit local data here, or by clicking at GMT time, add edit local data. This is the page where you can enter your local data. Let's say we are at 40 north, 40 east, and this is in Turkey, so it is, the time zone is 3 hours. Click OK. Now, if you want to enter the current GMT time at this exact moment, you will click at GMT time and current GMT time. Now, you can enter any point on Earth at these 2 boxes. This is the latitude and this is the longitude. So you can enter any data you want here in terms of latitude and longitude, or you can just click at latitude and apply your local data, and immediately you will find that in this box it is 40 north, 40 east, which is your local data. We can also click here and choose a city. There is 36 cities in the database in this application, and you can add more. You can click at options and add new city. You can choose the city by clicking at the first action box, and this is Beijing, and this is the location of Beijing being entered to the data entry area. And if you notice, the time zone is 8 hours for this location. Here we can enter the object that we are looking for. At the moment, the object is pointing to the sun, and this is, as I said before, the data related to the sun for this specific location, for this specific date and time. There are a lot of terminologies in this data area, and I did clarify the terminologies in the note. If you click options, notes, terminologies, and these are the terminologies that are used in the data table. Now, if you click at object, you have many objects here. You can choose the moon, and you will see the moon here being plotted in this attached image. You can choose one of the planets, let's say Mercury. This is the data for Mercury for this specific location and this specific time. And if you noticed, the plot of Mercury is here. You can choose one of the stars. There are 372 stars in the database in this application, and you can add more stars. Click Options, add a new star, and this is a page where you can enter the details of the new star. And you can choose the star by clicking at the first action box. Now this is the star table for Sirius, the brightest star in our sky, for this specific location and this specific time. And if you noticed, this is the plot of Sirius in this graph in terms of its azimuth and altitude. However, let us be more accurate about the data table, whether it was for the sun, the moon, the planets, the stars. Not all the data in the table are specifically related for location or time. Some of the data are fixed, some of the data are specifically related for time only, and some of the data are specifically related for location and time. So for example, the right ascension for the star is a fixed data, the same for declination. The elongation is not related for the location, but it is related for date and time. The azimuth and altitude are two parameters that are related for location and are related for date and time. However, the most important two parameters that we use to observe an object in a specific location are the azimuth and altitude. This is why I constantly clarify that the table is for specific location and specific date and time. Let's speak now about the control panel, but let us start first by pointing the object to the sun. Click Object, Sun. Talking about the control panel, I can use the control panel to increase the values in the data entry area, these values. There are many parameters in this control panel, and I can select one of them by clicking at Choose. I can increase the date by years, month, days. I can increase the time, latitude, longitude. I will speak about time B later on. It's at the moment pointing to time, and I can use these three boxes for time. This is for hours, minutes, seconds. And I can use the same three boxes for latitude and longitude. This will be for degrees, minutes, seconds. This box is for days, months, and years. It is pointing at the moment at time, and it is 1 hour. If I click next, the time will increase by 1 hour. Next. So this is the data table for this new time. I can click previous, and we return back to the original time. I can increase the time by 10 seconds, for example. This is 10 seconds. It was 37 seconds here, and now it is 47. And I can click previous, returning back to the original time. Clear? I can choose latitude, for example, and I can increase it, let's say, for 5 degrees. It is now 39 degrees. Click next. Now it is 44, and the data here is for this specific location, new location, and this time. And I can click previous. I can choose year. I can put 1 year. It is 2022. If I click next, now it is 2023. Click previous, returning back to the same date. And the same is, and I can click, for example, for 10 years. It is now 32. Click previous, returning back to the same date. Now I want to speak about the 4 graphic pages in this application. This is the first one. And let's put a star here. So this is the first one, and this image plot Sirius, the star we choose, in this graph according to the azimuth and altitude. Now we can make this image larger. This one is a larger image to this exact image. This is the same image, except that this is larger. This page has the data entry, and it does have the control panel, so I can increase the values of these data. Now I'm going to speak about the azimuth and altitude in more details in the next video. However, if you are facing the object, let's say you are facing Sirius, then the altitude is the angle from the object to the horizon. This is the altitude. The azimuth is if you are facing Sirius and that is your direction, then the azimuth is the angle at the horizon, or if you want the angle at the ground, from north clockwise to your direction. Now this is a 2D image, and we are trying to represent 3D space. Therefore, we need a little bit of imagination here. The altitude here, you need to look at it like a circle. This point is exactly the same as this point. This is at 90 degrees altitude. And the same here. This point is exactly the same as this point. And this is minus 90 degrees. So the altitude needs to be looked as a circle. And as I said, I will explain this more in the next video. Now, at each object, we have a clarification. Here, Sirius south, Sun south, and the Moon south. In the azimuth, we have 2 scales, one for the north and one for the south. If the object is clarified as south, you need to use this scale. If it was clarified as north, you need to use this scale. Now, we plot the azimuth as a square, but it is actually a circle. You are facing north. When you are at 0, you are facing north. When you turn 90 degrees, then you are here and you are facing east. And this point is the same as this point. And when you turn another 90 degrees, you face south at 180 degrees. And when you turn another 90 degrees, then you are at 270, which is west. And this point is the same as this point. And when you turn 90 degrees, you are back to north and you are facing north. So you need to look at it as a circle. As I said, we are trying to have the best 2D image that can represent a lot of information related to 3D space. Now, Sirius is clarified as south. Now, you are looking to the north. North in front of you, south behind you. You are looking to the north. Sirius is here. This means that the altitude of Sirius is about 15 degrees. But because it is clarified as south, then Sirius is actually behind you. If you are looking to north, Sirius is at your right hand behind you. And the azimuth of Sirius is about 125. So if you are turning around and facing north, if you are turning around and facing south, Sirius will be at your left hand. But if you are facing north, then Sirius will be at your right hand behind you. Now, above this line is above the horizon, and this is what we clarified here. This is above the horizon. From here down is below the horizon. This is above the horizon, and this is below the horizon. Now, the moon is below the horizon, and this is why the altitude is in negative. If we are able to see through Earth, we will find the moon at about minus 10 degrees to our position. To our location, it is minus 10 degrees and at about 255 azimuth. So this graph plots the objects above the horizon and below the horizon. And the control panel is pointing to time, and I can click next and I can see how these objects move with time around my position. So if you click next, I will speak more about this graph in the next video. To go for the third and fourth graphic pages, click Options, Graphics. You have the star chart and solar system. Click at star chart. If this was empty, if this box was empty, you can just click default, because this is the default value. AP means all planets. F10 means the 10 brightest stars in our sky. There is note here, and it will give you an idea of how to select more objects. For example, I can select another 5 objects, S50 to 55. This means that I'm selecting all the planets, the 10 brightest stars in our sky, and the stars from 50 to 55 in the database. Click OK. And these are the objects I have selected. It is the same exact graph as this one, but this one is larger. This one is wider. And you can add data. This is the data entry area, and you have the control panel. And the parameter for the control panel is pointing to time. And if I click next, I can see the objects move through time around my location. The planets are in green and the stars are in blue. Click Exit. To go to the fourth graphic, click Options, Graphics, Solar System. This represents the planets around the Sun. The red are the planets, the blue is the Earth, and this small sphere is the Moon. There is the data entry here, and this is the control panel, and it is pointing to day, so you can click next and you see the movement of the planets per day. You can click choose, click month, and you can see the movement of the planets per month. The big letter here near the planets represent the planet's initials. M for Mercury, V for Venus, M for Mars, E for Earth, etc. There are fine printed letters around the orbit of the planets, and if you are unable to see them clearly, click at Options and Magnify. So you can see at the top of the magnifier the letter A and Max. The meaning of these letters can be found in Options Note. So A is the aphelion, which is the maximum position of the planet to the Sun. That point is at the maximum position of the planet to the Sun. P is the perihelion, which is the minimum position to the Sun. Max is the maximum heliocentric latitude, etc. Before leaving this page, I think I need to clarify one thing. The distances here in this graph are not to scale. I think this is obvious, but the angles are accurate. Exit. I'm going now to speak briefly about time B. There is a note here. 1 hour extra in time B will also push the longitude 15 degrees to the west. Therefore, the Sun will look like standing still. So let's point to the Sun. Click Functions. What I want here, I want to find the longitude at this particular time that the Sun will be at sunset. This is the function required, longitude at sunset at this particular time. This is a double click window. It is double click. So double click here. This is the answer. And double click here to apply this result. And at this particular time, at this particular latitude, this is the longitude where the Sun is at sunset. Let's click at time B and let's add 1 hour. When I click next, this time will be increased by 1 hour, but this longitude will be pushed 15 degrees to the west. Therefore, the Sun will continue to be sunset. So I am moving with the Sun. The Sun is almost, with time B, is almost standing still. So if I click next, it is 7 o'clock GMT and I'm being pushed 15 degrees to the west and it is sunset. Click another next. It is 8 o'clock and I've been pushed 15 degrees to the west and the Sun is at sunset. There are many other features in this program that I can speak about for hours, but I think in this video I managed to give a good guide about how to start this program, and there are many notes in this program that can give you a good idea about the features that we didn't speak about. I hope this video was useful and thank you for listening.